In this question, we have a wire with a voltage difference of 3.24 nanovolts, and this is a copper wire, so the resistivity is going to be 1.69 e to -8. But we're asking to find the charge that's passing through this wire in this very small amount of time here. And in order to do that, we're going to have to remember the equation that relates charge and time. So it's going to be like Q equals IT. So all we need to do is figure out what the current is through this. In order to do that, let's try to remember that current is equal to voltage over resistance. And so we need to figure out what the resistance is, because we already know the voltage. So voltage is going to be like this 3.24 e to the -9 volts, and then the resistance is going to be, well, let's see, the resistance is supposed to be resistivity times length over A, and we already know the resistivity, so we'll plug that in there. It's going to be 1.69 e to the -8 ohms meters, and then times length over A, so we'll kind of make a big brackets here, and we'll say the length is going to be 2.05 e to the -2, and then the area is going to be pi, and then r squared, so just 2.13 e to the -3 squared. So now we've got what the current is, and all we need to do is multiply it by the time to get the charge. So up here, we're going to multiply this by our time, which is 3.07 e to the -3 seconds. Okay, and then now we can try to plug this into the calculator and see what happens. So we'll just basically say that, we'll set up a big thing, and we'll go 3.24 e to the -9 times 3.07 e to the -3rd, divide that by 1.69 e to the -8 times, big thing up and down, 1.05 e to the -2, and divide that by pi times 2.13 e to the -3 squared. Bam! And we get our answer of the Q is equal to 4.1 e to the -7 coulombs. All right, not too bad.